Okay, so today we're gonna dive deep, into some algebra 2,
Yeah,
probability and statistics.
a little bit.
And we're looking at some, pretty basic stuff here, but I think, we can all use a refresher sometimes.
Absolutely. I mean, it's
Hmm.
always good to go back to the fundamentals, right? And really make sure we have those solid before we start building, more
Mm.
complex ideas on top of them.
So true. So true.
Kind of like a foundation of a house.
Yeah.
Got to make sure that's strong.
Yeah, exactly.
All right. So, what are we looking at here? What kind of stuff are we diving into?
So we got probability rules, the basic idea that the chance of something happening is, somewhere between 0 and 1.
Right. Zero meaning it's never going to happen, and one meaning it's absolutely going to happen.
Exactly,
And everything in between is, the likelihood or the chance of that thing happening.
Right. And then to figure out those chances, we got to look at counting principles, right?
Yeah, counting principles. These are the tools that we use to kind of figure out how many possible outcomes there are in a given situation.
So it's not just like counting on your fingers, right?
No, it's much more sophisticated than that.
Okay.
It's really about thinking about all the different ways that something can happen and then having a system for counting those possibilities accurately.
Okay. I see. That makes sense.
So imagine like flipping a coin, right?
Yeah.
You have two possible outcomes, heads or tails.
Right.
But what if you flip it twice?
Oh, then it gets a little more complicated.
Exactly. You've got heads, tails, heads, tails. So four possible outcomes.
Ah.
And that's just with two flips. So imagine if you're flipping it 10 times.
Oh, my gosh.
That's where counting principles come in. They give us the tools to figure out how many possibilities there are without having to list them all out.
Okay. That's super helpful.
It is, and it's the basis for understanding probability. Because
Yeah.
once you know how many total outcomes are possible, you can then start to figure out the probability of a specific event happening.
Right. Okay. That makes sense.
All right, so moving on, then we got permutations and combinations.
Oh, yeah. These are always fun.
Right, these can be a little tricky. But think of it this way. Permutations are all about order.
Order matters.
Exactly. So like if you're arranging books on a shelf, the order in which you put them matters.
Yeah, because it's a different arrangement if you swap two books.
Precisely, that's a permutation, but combinations are different.
How
Well,
so?
with combinations, order doesn't matter.
So it's like picking toppings for a pizza.
Yeah, exactly. It doesn't matter if you put the pepperoni on first or the mushrooms on first, you still end up with the same pizza.
True. True. So order doesn't matter in that case.
Right, so that's a combination, and that's a key distinction to remember because it affects how we calculate the number of possibilities.
Okay. So permutations order matters. Combinations order doesn't matter.
You got it.
All right. So then we move into measures of central tendency and dispersion.
Ah, yes. Getting to the heart of statistics here.
Right. So measures of central tendency, these are all about finding that, typical or average value in a set of data.
Exactly. And we have a few different ways to do that, the mean, the median, and the mode.
Right. And the mean is just the average, right? You add
Yeah.
everything up and
Yeah.
divide by the number of values.
That's right. While the median is the middle value when you arrange the data from least to greatest.
And the mode is the value that appears most often.
Exactly. So each of these measures tells us something different about the center of the data.
Okay, but it's not just about the center, right? We also need to know how spread out the data is.
Absolutely. And that's where measures of dispersion come in, like the range and standard deviation.
Right, so the range is just the difference between the highest and lowest values.
Easy peasy. And the standard deviation tells us how much the data points deviate from the mean.
Oh, so it's a measure of how spread out the data is around the average?
Precisely. A larger standard deviation means the data is more spread out, while a smaller standard deviation means the data is more clustered around the mean.
I see. So we can have two sets of data with the same mean, but very different standard deviations.
Exactly. Which is why it's so important to consider both measures of central tendency and measures of dispersion when analyzing data.
It gives us a much more complete picture, right?
Absolutely.
Okay, and finally we come to probability distributions.
Oh, yes. This is where it all comes together.
It sounds kind of intimidating, though.
It might sound fancy, but it's really just a way of showing all the possible outcomes of a random event and how likely each outcome is.
So, like, with flipping a coin, we have two possible outcomes, heads or tails, and each has a probability of 0.5.
Exactly. A probability distribution just expands this idea to situations with more potential outcomes.
Okay, so it's like a map of all the possibilities and their likelihoods.
That's a great way to think about it, and we use probability distributions to model and analyze all sorts of things, like the outcome of an election, the number of defects in a manufacturing process, or even the weather.
Wow, so it's a really powerful tool.
It is, and it all builds upon those foundational concepts we talked about earlier: counting principles, probability, and measures of dispersion.
Right, so it all ties together in the end.
It does, and that's the beauty of it. It all starts with these basic ideas, and then we can build upon them to understand increasingly complex phenomena.
That's so cool.
It is, and it's just the tip of the iceberg. There's so much more to explore in the world of probability and statistics, but hopefully this deep dive has given you a good foundation to start from.
Yeah, absolutely. I feel like I have a much better grasp on these concepts now.
Great, and remember, these ideas are not just confined to textbooks.
Right, they're all around us.
Exactly. Think about how they're used to predict election results, to analyze financial markets, to make medical diagnoses. The list goes on and on.
So it's really important stuff.
It is, and the more you understand these concepts, the better equipped you'll be to navigate the world around you.
So true. So true. Well, that's all the time we have for today, but hopefully this has given you all some food for thought.
And remember, math isn't just about equations and formulas. It's about understanding patterns and making sense of the world around us.
Well said. Well said. Thanks for joining us today.
It was my pleasure.
And we'll see you next time on The Deep Dive.
See ya.
Bye.